Jeremy, as you can see, this is a UHF Gold Chassis Quantar. It's exactly the same kind of repeater that you have, except yours is VHF. On the table I have the Quantar, I have a dummy load, and I have an SCOM 7330 controller. There's two kinds of cables that I have here. There's the standard cable, which has a DB9 connector, a metal housing, an RFI ferrite bead, a very heavy-duty shielded Amphenol DB25 connector, the TE connectivity Quantar specific power connector, and in the case of the SCOM 7330 repeater, you have a two-position Phoenix connector. This is similar to what you would find on the RCOM repeater, different however than you would find on your Link Communications repeater and on I believe the other repeaters that you were mentioning that you had use a barrel style connector. We'll get those for you. So I'm going to turn the repeater around so you can see what we're talking about. As you can see on the back of the station, you have all the connectors that you have on all bands of Quantar. You have a telephone style connector, a 50-pin telco or Centronics connector, transmit and receive, and you have J14, which is going to be the port we're focusing on, which is the MRTI/trunk and control port. These different ports you can read about on the station backplane manual, but for our purposes, this is what we're interested in. This port right here is going to allow you to connect the SCOM 7330, this controller right here, and allow this repeater to now be controlled by this machine. The way we have this repeater programmed is as a base station. So this is no longer a repeater in the customer programming software, it's a base station. And to show you how we've programmed that, I'm going to turn this around again. I have a handheld radio here, and it is tuned to this repeater's receive frequency, which is right now in the ham band. And if I go into transmit, you'll be able to see that receiver 1 is activated because we have an active and correct PL tone, and it's on the proper receive frequency. However, you can also see that the power amplifier is not doing anything, and you might be able to see the watt meter here is not registering anything. So we have a receiver, but it's not transmitting because it's got nothing to control it. So I'm going to go ahead and turn this around again, and I'm going to show you how easy it is to connect your controller. So what we're going to do is we're going to start with the standard Quantar cable. This is not the advanced cable. And the first thing we're going to do is take these Velcro tie wraps that come with it off. These are not going to be disposed of. You're going to use this on the back plane of your station to secure this. You only need to remove one. You're going to take the 25-pin Amphenol connector. You're going to plug it into J14. This will not change no matter what kind of controller that you're using. That's your first point of connection. For demonstration purposes, I'm not going to screw this in, but 2 screws are provided. The next connector is the power connector. It's a TE connectivity 10-pin connector. That's going to connect to J27 right here. You're just going to plug that in. It's a gendered connector, so you can only plug it in one way. And that's secured right there. This circuit is auxiliary power. It's rated for up to 1 amp continuous duty on this station. A repeater controller is going to draw much, much less than that. In the case of this demonstration, we're going to take our SCOM controller right here. I'm just going to place it on top of the repeater. And I'm going to plug it in. It doesn't matter, but in this case I'm going to plug it into port 1 because that's what I've programmed to work on the SCOM controller. The SCOM controller program is similar to any other controller. You have to set any of the internal settings to work with this machine. It's really uncomplicated, but you should be aware that that's going to be required. And I'm going to go ahead and I'm going to plug this in a minute. But first I'm going to turn the volume up on this portable radio so we can hear this repeater identify. Finally, we're going to plug in power.
The controller has reset. Please stand by.
As you can see, the controller just did a power reset, but that audio came over this radio, which means this repeater transmitted in its transmit mode because it was originally in base station, and now the controller is taking over that operation and it's functioning as a repeater. To finish the installation of this cable and this kit, you're simply going to dress these wires, putting the ferrite bead up into the air like that. You're going to take one Velcro tie wrap, you're going to tie it around the receive and the transmit cable. Right around. Just tuck that right in there. You're going to take the final tie, you're going to remove it from the wire, the paired wire. And in the case of this installation, it makes the most sense to attach it to the receive coax right out of the back of the receiver housing. And of course you can do this any way you wish depending on your application, but for this demonstration this will be adequate. Because the programming has been done to the SCOM 7330 and the Quantar, the installation of this controller is finished. Now I'm going to turn the repeater around. We're going to see exactly what has happened in the front of this controller. This is a handheld radio programmed to this repeater's transmit and receive frequency. And I'm going to go ahead and transmit, and we're going to see a couple things. We're going to see push to talk, carrier operated relay, and encode on port 1. As you can see, as I transmit, we have PTT, carrier operated relay, and encode. Just because of the way this is programmed, ports 2 and 3 are also in transmit mode. I'm going to release this radio's push to talk button, and we're going to hear the repeater identify.
Tuesday, 19 hours, 18 minutes. This is the KG2NB repeater.
Now, one thing I want you to notice, and this is important for the people who want to use Echolink or an IRLP node, I'm going to transmit. You can see we have our receive 1, we have our PA full power. In this case, it's only 50 watts because I've turned it down, I've derated it. But as I release this push to talk button, the encode light is going to go away as the PTT remains on for the hang time. Now I'm going to do that one more time because what you're going to hear is what sounds like a Nextel beep. It happens to be this controller's courtesy tone, and it's going to release encode by sending a logic low to the back of the MRTI connector. But look at the timing of when this happens. We heard that courtesy tone well after the encode light went away, which means over an IRLP node you would have heard nothing. So that concludes the demonstration for the basic cable. The advanced cable is simply the basic cable, but in the case of the SCOM 7330, we utilize one of the outputs in the rear of the controller to allow us to strip PL and place this repeater into a monitor mode. I'll just turn that around and show you what it means for this controller. On the back of the SCOM, much like the RCOM, you have port 1, 2, and 3. You have power, and then you have I/O. These are your logic points. I'll just move the camera up so you can see that more clearly. Now, it's at these logic points that we can control certain functionalities via DTMF, or just make them sort of macro controls. In the case of this repeater, with the advanced cable and the way that this is programmed, I can put this station into open monitor requiring no PL. For the purpose of this video, I'm not going to demonstrate that because I think you're going to have the idea. When I build your cables for your link controller and the other devices that you indicated, you're going to have all the same functionalities. It's going to do exactly the same thing, and it's going to be this easy. I'll talk to you soon.